Hello, geometry classes. We are going to be starting lesson 2.6 or C2L6 today. So hopefully you have this. Remember, it's posted in your class notebook. Let's put our name on our paper and whatever period you're in. Today is October 14th. Our objective in this is that students will be able to prove theorems about angle relationships. So this is a pretty hefty section in that we have a bunch of theorems. We are not going to prove every single one, but I'll tell you where to find the proof if you want. Otherwise, after today, you'll be able to use all these theorems in subsequent proofs. So here's some general rules. Most theorems are stated in conditional form. So remember that means if then, when we did the if P then Q. So if you have something, then you get something. If you want to prove a theorem, you would use the if as if that's the given and the then as to what you want to prove. So if I talk to you about the right angles congruence theorem and you wanted to prove it, it's all right angles are congruent. This is how you can abbreviate it. All right angles are congruent. So it's not writing it all out, but it would be like, if you have right angles, then they are congruent. Now, I'm actually not going to do the proof in here because it's in your book and I'd like you to look at it on your own. It's on page 106 in the text. It is the very first example. But it's almost sort of an obvious one, right? All right angles are congruent. That's actually a theorem that we can use. The next one is congruent supplements theorem. So let's read it. If two angles are supplementary to the same angle, or two congruent angles, then those angles are congruent. And so again, you can highlight it, abbreviate it like this, congruent supplements theorem. The proof here is going to be on page 107 in your text, and this is example 2. Otherwise, we're going to sort of assume that, yes, this is what we have, and it's going to be true. Just like the supplements, we also have a theorem that says that congruent complements theorem. If two angles are complementary to the, again, it has to be the same angle, or two congruent angles, then those angles are congruent. I think I'm going to do a little color here. So this is how we're going to abbreviate them. This is the congruent complements theorem. And then this one here, this proof, it says use the proof of the congruent supplements theorem from homework 2.8. Now, as a reference to help you write a 2-column proof for this theorem. We actually were going to do these exercises in class on Friday. So if you want to see the supplements theorem proof from here, look on page 107. In the meantime, for the purpose of these notes, we're going to go ahead and do the proof so you can fill out the notes. And here's how we're going to start. Our given is that angle A is complementary to angle B and angle C is complementary to angle B. What we want to prove is that angle A is congruent to angle C because they're both complementary to angle B. So this theorem says that they will be congruent to each other. So again, we sort of want to talk this out. How are we going to get that to happen? Well, if these are complementary, then they add up to 90 degrees. If these are complementary, they add up to 90 degrees. So if they both add up to 90 degrees, I can set them equal to each other. And then if they both have a B on each side, I can subtract angle B, the measurement of. And then I end up with the measurement of these angles equal. So then I'll end up with them being congruent. So I can sort of talk myself through it. Remember, please always use a straight edge so we have nice, crisp edges on our statements and our reasons. So these are our statements. These are our reasons. And if it helps, draw a picture on the side. So first step is always write down what you are given. You're given A is complementary to angle B, and angle C is complementary to angle B. Whoops, I wish I'd made it just a little bit longer. So step 2, we're going to write down what that means to be complementary. So what it means is that the measure of angle A plus the measure of angle B is equal to 90 degrees. And since it's the same reason, we're going to put it on the same line. So the measure of angle C plus the measure of angle B is also 90 degrees. That is the definition of complementary. You could write it like this. A complement adds up to 90 degrees. If you have a complement, angles add up to 90. Then the third thing we can write, keep them right across from each other. Since they're both equal to 90, you can set this equal to this. So the measure of angle A plus the measure of angle B is equal to the measure of angle C plus the measure of angle B. That is called the transitive property of equality because they're both equal to 90. Then number 4, we are going to subtract this from both sides of our equal. So that now I have the measure of angle A is equal to the measure of angle C by the subtraction property of equality. And finally, our last step, if the measurements are equal, then I can say that the shape of the angles are also congruent. And so the way we've been writing that is if it's equal, if and only if it's congruent. I'm just going to keep trucking along here to go, so that these notes won't take you too long. The next thing we have in section 2.6 is a linear pair postulate. Linear pair postulate. What it says is if two angles form a linear pair, so you have to have a linear pair, then they are supplementary. So here's how you can abbreviate it. Linear pair means supplementary. And remember, we don't have to prove this because postulates are accepted without needing a proof. It's just one more tool in your tool bag that you'll be able to use along with these theorems. So if you need to write anything else down, pause the video. Otherwise, I'm going to turn the page and keep going. So we're going to talk about 2 more. I told you there were a bunch. This one is one of my favorites. You'll be using it all year. It's called the vertical angles congruence theorem. And it's just a fact that vertical angles are congruent. And the cool thing is they look congruent too. So it's sort of one of those things that look obvious. Now, if you do want to look in your book, I am just going to add that this proof is on page 108, or maybe you want to see the picture better or something. It is example 3. But what you have here is a runway. There's a little plane. And you've got angle 5 across from angle 7, angle 6, and this one just doesn't even show up. So you're given, let's mark given, that angle 5 and angle 7 are vertical. So these are vertical. What we want to prove is this. You're given that they're vertical. Now, there's a big hint here. We're going to use the linear pair postulate from the previous page and something else from the front side. So I'm just going to go ahead and write it out, and you'll see how it works to use another one. Normally, like I've been doing, is I would just sort of sketch out how I want this to happen. But in these notes, really what I want you to try to be figuring out is, what would you do next? So here's statements. Here's reasons. So number 1, angle 5, angle 7, and you just say are vert angles. You can just say that because that was given to you. Okay. Now, what else I can do is I can look at my picture here and notice that this is a straight line. Therefore, 5 and 6 form a linear pair. So for my next step, I'm going to write angle 5 and angle 6 are a linear pair. We defined that a long time ago. But I also know by looking at this that this straight line is a linear pair. So what I'm going to do is on the same line, I'm going to write that angle 7, angle 6 are also a linear pair. I should have gone over just a little bit more, because that is the definition of what we call a linear pair. Just a straight line of 2 angles. Now you may actually be seeing, because we did in our notes on Tuesday something just like this, only the angles were like this. So hopefully your creative juices are flowing and you can see. What we're going to do is we're going to say that angle 5 is supplementary to angle 6. And also, by the same reason, angle 7 is supplementary to angle 6. Because we can say this by the linear pair postulate. The linear pair postulate says that linear pairs are supplementary. Isn't that nice? Because once we have that, then all we have to say right here is that angle 5 is congruent to angle 7. Literally, like we don't have to go through all the plus and minus and all that, because the congruent supplements theorem on the front says that we can go from here to here. If they are both supplementary to the same thing, then they are congruent to each other, and that's how you use that. Very handy, wouldn't you say? So for the next, that's 5 theorems or 4 theorems and a postulate we just went over. So now here's a couple of relationships that we can use to do problems. We will be doing, that's not all of section 2.6. We'll be doing more of that on Thursday. This should be enough to get you started on problems. Okay, so the first thing we're going to do is we're going to read the problem. Find the value of x. Start your work with a letter equation. So let's just see where x is. Okay, here's x, 3x plus 1. So I'm noticing that these are across from each other. That's what we call vertical angles. So this is going to equal this. And when it says start your work with a letter equation, what it means is don't just go straight to x. It means an equation, right? An equation. So that means 3x plus 1 equals 148. That's starting with a letter equation. Of course, we're going to make sure we do everything to make the x alone, which of course you can do because you're all excellent algebra students. And sorry about that beeping. And so x is 49. And find the value of x, x equals. If you want to check it, just pop that 49 right in there. 3 times 49 plus 1, it should give you 148. And whenever I check it, I always give myself some kind of happiness mark. Yay. Okay, now for number 2, there's 2 parts. This is the same picture for both. And so what it's saying is describe and correct the error in using the diagram. So when I'm looking at this diagram, like if I were gonna highlight stuff, for instance, this is saying equal to 180. So I'll be looking at either these pairs, this one, or this one. I mean, those pairs. So it says 13x plus 45. That's this one here, as you can see, plus 19x plus 3 equals 180. Do we know that those together are equal 180? No, that's not what it should say at all. These do not make a linear pair. So instead, we should take this out because nothing past this actually works. So cross all that out. And what we know about vertical angles, is that this is equal to that. So over here, what you should actually write is 13x plus 45 equals 19x plus 3. And you're going to solve that equation. You're going to take away 13x from both sides so that you get 6x. And then you're going to take away 3 from both sides, so you get 42. Then you're going to divide both sides by 6 to get x equals 7. And that's all you have to do on these problems is find x. Okay. Now I will look at the next relationship. Okay, for B, 13x plus 45 is here, plus 12x minus 40, which is here, equals 90 degrees. So you should see that this plus this is not 90. The error here, of course, is that it's equal to 180. So all that goes away. And you can just go straight from here to the work over here. Here's your equation. What I'm going to do is I'm going to add my x's together first. So 13 plus 12 is 25x. Plus 45 minus 40 is going to give me plus 5. That equals 180. So if I subtract 5 from both sides to make that go away, I've got that. And now if I undo the multiplication by 25 by dividing, then I get x equals 7. And I'm done. For now, of course, I could plug it in and make myself with a happy star there. But that's the end of the notes for now. We will do more tomorrow. And I look forward to seeing you. Okay, so now I need to stop my recording.